In this video, we are going to discuss nanotechnology. Belongs to module number 5 in engineering chemistry. Let us see the syllabus of nanomaterials. Introduction, size dependent properties, surface area, electrical, optical, catalytic and thermal properties. Coming to the synthesis of nanomaterials, top down and bottom up approaches. We have sol-gel method, precipitation and chemical vapor deposition method. Coming to the nanoscale materials, we have fullerenes, carbon nanotubes and graphenes, their properties and applications. I will give a small introduction about nanomaterials. The materials of at least one dimension between 1 nanometer to 100 nanometer are known as nanomaterials. A nanometer is 1 billionth of a meter, that is 10 to the power of minus 9 meter. Coming to the surface area and catalytic activity, it is observed that when the materials are reduced to nanoscale, they show different properties as compared to the properties exhibited by them at the bulk level or micro level. At nanoscale, optical properties, thermal properties, mechanical and electrical properties may change, and these new properties are used in various fields. Nanomaterials have a significant proportions of atoms existing at the surface. Properties like catalytic activity, gas adsorption and chemical reactivity depends on the surface area. Therefore, nanomaterials can show specific related properties that are not observed in bulk materials. One of the important reasons why the properties changes when materials are reduced to nanoscale. In nanoparticles, surface area is very large. Atoms on the surface of a material are often more reactive than bulk. So that nanomaterials of a material show different properties compared to larger particles of the same materials, like gas adsorption, catalytic activity and chemical reactivity is more in nanoparticles. Coming to the electrical properties, as size decreases, the electrons of the nanoparticles confined to a small space and the band gap increases in some metals which are good conductors become semiconductors or insulators as their size decreases in nanoscale. Because of the presence of more atoms, there is an overlapping of orbital takes place. As the size decreases, orbital becomes separated and there is a gap between the bands, that is valence and conduction bands. This decides the nature of the nanomaterials. So that the nanomaterials exhibits good conductors in bulk, semiconductors and insulators exhibits when their size decreases to nanoscale. Then coming to the optical properties, nanomaterials in general can have peculiar optical properties as a result of their light interaction with fine structure. The reduction of material dimensions has a prominent effect on the optical properties of nanomaterials. Decreasing the size of nanostructure materials increases the energy difference, delta E, between the higher energy level and lower energy level. When an electron drops from higher energy state to lower energy state, light is emitted with wavelength that is larger. Delta E implies shorter wavelength and the color of the nanomaterial different from that of materials. Means nanoparticles of a material show different optical properties compared to larger particles of the same material. Coming to the thermal properties, melting point decreases when a particle's size is reduced to nanoscale. In this, nanoparticles of a material show high thermal properties compared to larger nanoparticles or bulk particles. Because the surface area is very large in nano size compared to bulk, so that thermal properties increases. As the metal particle size decreases, the melting temperature also decreases. For example, the gold nanoparticles with a diameter less than 3 nanometer experiences a much lower melting point, close to 500 degrees Celsius, as compared to the bulk gold melting point 1064 degrees Celsius. Means, which tells about that nanoparticles of a material shows high thermal properties, means the temperature decreases with the decrease in size. That is about thermal properties. Thank you.